I apologize, I don't know what happens at the end of that this video, but we were here while we were talking about the unit cube and taking our knowledge from 2 dimensions and patterns from 2 dimensions and applying them to 3 dimensions. And I had just gone to this website and or this GeoGebra sketch of my unit cube, where I have the 3D unit vectors 1, 0, 0, 0, 1, 0, and 0, 0, 1 on the X, Y, and Z axes, and then also the position vector 1, 1, 1. Of course, you can always think of, yes, there's another vector, it's the 0 vector at 0, 0, 0 if you like. But this is my unit cube using all of those vectors, right? The unit vectors and the position vector 1, 1, 1, and the cube that results. And you can see down here that the GeoGebra applet calculates the volume of that cube. And so the way I have this set up, the only thing I can move here is along here, but you can see the same kind of thing is going to happen. And if I take this all the way out to, if I scale this by 2, can't quite get it exactly. Come on, come on, come on. Right, it obviously should be 8. Right, and it's just, there we go. Oh no. You get it, right? That the volume is, if I scale this correctly, this should be an 8. So that the determinant, and if you do the determinant of this matrix, right, of what the resultant matrix of the transformation, you're going to get 8 when you're done, right? Whoa, check out that. Isn't that pretty cool? All right. So if we indeed talked about this transformation, right, what would the transformation matrix look like? That made my cube a 2 by 2 by 2, right? Wouldn't that transformation matrix my unit vector at 1, 0, 0, at 0, 1, 0, and at 0, 0, 1 would all be scaled this way, and then what would that would be the transformation matrix, and then the resultant matrix would look just like that. Right? And this is what the resultant 3 by 4 matrix would look like. But what is the determinant of my transformation matrix? Right? Remember to do a 3 by 3 matrix. We're going to get 2 times this small matrix, which is 4 minus 0. And then I think you can see what happens with the rest, right? With 0 and 0 here, I'm going to get 0 times who cares and 0 times who cares. Add those all together, and sure enough, I get 8, which was the volume of the 2 by 2 by 2 cube that I got as a result of this transformation matrix. So the last slide was just some practice, right? So first back to 2 by 2. What matrix is the result of this transformation? So I'm asking you if this was my transformation matrix and I'm operating on the unit square, you would say, well, the unit square in 2 by 2 looks like this, right? And my transformation matrix looks like this. This is my transformation matrix and this is my unit square. This is a 2 by 2 matrix and this is a 2 by 3 matrix. So my resultant matrix is going to be a 2 by 3. But you can skip the multiplication, and part of your homework I ask you to, sometimes I ask you to write out, the last problem I actually ask you to write out the multiplication, but my goal in showing you patterns here is that you can skip the multiplication, right? And tell me that what is my resultant matrix going to be? We know the resultant matrix is going to be, the first column is where 1, 0 ended up. The second column is where 0, 1 ended up. And then the sum is where the 0.11 ended up. Right? So, and I could draw this. Negative 19, 1. 4, 2. And negative 15, 3. Right? These are my position vectors. What is the area of that resultant parallelogram? Yes? And don't forget to take the, right, so the determinant of the transformation matrix, but you're going to take absolute value of that because they asked for the area. Right? And you should get negative 42, if I did my math right, is the answer to the determinant, but again, the answer to the area would be 42 units squared. Okay, so just a little 2 by 2 practice, and then this again is asking about 3 by 3. What does this transformation do? Okay, so we already just saw in the previous example on the previous slide, you know what that's going to do to your cube, right? So this is the transformation matrix. This is going to operate on your 3 by 3 unit cube. But using our pattern, you don't actually have to multiply. Again, although multiplying with these 1s and 0s ain't no big deal. The column that represents the x unit position vector is 2, 1, 1, 0, 2, 0, and 0, 0, 2. And then remember what happened to the point out there in space. The 1, 1, 1 vector is a sum of the rows, so I end up with 2, 2, and 2. I'm sorry, 2, 3, and 3. Okay? So your homework assignment asks you to do some operations like in 2x2 here, ask you to do perform a linear transformation, what's the image, sketch it, find the area. Then I ask you to do a bunch of 2x2 without, a bunch of 2x2 transformations where you, again, sketch the image, find the determinant. You don't hopefully actually have to do the multiplication, that you can just use your pattern. And then the last problem that I ask you to do takes a non-unit square. So I give you a rectangle and ask you to perform transformations on that particular rectangle. And then I ask you to actually walk me through what the matrix multiplication looks like and what the effect of that matrix was on the original image. All right, so again, I apologize for the original video not being all the way complete. I don't know what happened, and I hope this fixed the situation.